Integration involving inverse trigonometric functions. These are the three basic formulas on integrations that will result to inverse trigonometric functions. Integral of d all over square root of a squared minus u squared equal to arc sine u over a plus c. And for du over a squared plus u squared equals to 1 over a arc tangent u over a plus c. Then you have du over u square root of u squared minus a squared equals to 1 over a arc secant u over a. So we'll have example on this one. Evaluate the following integrals. So integral of dx square root of minus x squared. So your solution, this one the form of integral of du over square root of a square minus u square equivalent to arc sine u over a plus c. But here your u is equivalent to x. Then yung a equals to 4. So substitute. So integral of dx over square root of 16 minus x squared should be equals to arc sine x over 4 plus c. On number 2, integral of dx over x square root of x squared minus 25. So you have the standard form already on this formula. This one belongs to integral of du over u square root of u squared minus a squared. The answer of which is equals to 1 over a arc secant u over a plus c, where your a is equals to 5, u equals to x. So direct substitution. So you have that one, integral of dx over x square root of x squared minus 25 equals to 1 over a. You have that one, 1 over 5 arc secant x over 5 plus c. Alright, we have that one on number 3. Integral of dx over x squared minus 1. So just follow the formula. So your solution, this was the form of du, integral of du over u square root of u squared minus a squared equals to 1 over a arc secant u over a plus c. So substitute integral of dx over x square root of x squared minus 1 equivalent to 1 over 1 arc secant x over 1 plus c, or simply you have that one arc secant x plus c. On number 4, solution. This one is in the form of integral of du over u square root of u squared minus a squared, equivalent to 1 over a arcsecant u over a plus c. So therefore, your integral of dx over x square root of x squared minus 25 equals to 1p arcsecant x over 5 plus c. So integral of x dx over 16 minus 9x4. So we have this one, solution. This one the form of integral of du over square root of a square minus u square equals to arcsine u over a plus c. So your u equals to 3x squared. Yung du equals to 6x dx. Your a equals to 4. So substitute that one equals to 1 over 6 times 6 dx over square root of 4 square minus 3x square quantity square, or equivalent to 1/6 integral of 6x dx over square root of 4 square minus 3x square, 3x square square. So simply equals to 1 over 6 arcsine 3x square over 4 plus c. Alright, this one, integral of dy over square root of 2y minus y squared. So what you do here is you have to rearrange such that you can use the formula. So first, rearrange the equation. So that one becomes integral of dy. Rewrite this one under form square root of 2y minus y squared minus 1 plus 1. So equivalent to integral of dy over square root of 1 minus y squared plus 2y minus 1. Or you can rewrite this one to integral of dy over square root of 1 minus y squared minus 2y plus 1. Or rewrite again to over square root of 1 minus y minus 2 square. So the form now is integral of du over square root of a square minus u square equals to arc sine u over a plus c. So the integral of dy over square root of 2y minus y squared would be written as integral of dy over square root of 1 minus y minus 1 square, or simply equals to arc sine y minus 1 plus c. Number on number 7, solution. So you have that one. Integral of dx over x squared plus 4x plus 5. This one could be written as integral of dx over x squared plus 4x plus 4 plus 1, or you can have that one equals to integral of dx over x plus 2 square plus 1 square. So the form is integral of du all over u squared plus a squared, which is equals to 1 over a arctangent u over a plus c, where your u equals to x plus 2, your a equals to 1, so it is equals to arctangent x plus 2 plus c. Right here on number 8, integral of dy over square root of 9 minus y squared. So this one, solution this one is in the form of integral of du over square root of a squared minus u squared. The answer is arc sine u over a plus c. So the integral of dy over the square root of 9 minus y squared is equivalent to arc sine y all over 3 plus c. Right here on number 9, integral of dt over t squared plus 2t plus 5. you can rewrite this equation form into form for the formula. So this one could be written as integral of dt over t squared plus 2t plus 1 plus 4, or equivalent to integral of dt over t plus 1 square plus 2 square. So the form is integral of du over u squared plus a squared, which is equals to 1 over a arctangent u over a plus c. So therefore your integral of dt over t plus 1 square plus 2 square is equals to 1 over 2 arctangent t plus 1 all over 2 plus c.